Okay, hey guys, just want to talk for a minute again about what transformations do to our function families. Okay, these are the parent functions for 5 of them. It's not all of them, we're missing linear. Okay, but linear is easy enough to graph on its own, so we're going to skip it for this. Alright, so we've got x squared, x cubed, absolute value of x, square root of x, and 1 over x. Okay, these represent the quadratic, cubic, absolute value, square root, and rational functions. Okay, our transformations are going to be controlled by 3 things. It's going to be h, which moves it horizontally, which is left and right. Vertical transformations are controlled by k, and a controls reflection and stretch and shrink. Okay, so let's take one as an example first. Let's use quadratic. Okay, so if I have f of x equals, let's say 3 times x minus 2 squared plus 4. Okay? Alright, you might be asked something like, what transformations are taking place on this function? Now, it's all relative to the original parent function, which is x squared. Okay? X squared is going to be, if you graphed it, it's just going to be sitting right on the origin, like so. Okay? So that is the original parent function. These numbers are going to change what it does. Okay? Now, let's look at our h, k, and a. Alright? Okay, when we add in h, k, and a into our generic function here, all right, they're going in these places, and each one of them serve their respective purpose. So if we follow this key over here, we can tell that a has a value of 3. Okay, so if a equals 3, well, that's going to control reflection and stretch and shrink. Well, if it's negative, it's going to be reflected. This is positive. So no changes going on with regard to reflection. Stretch and shrink deal with the value of this. Okay? The value is greater than 1, which it is. It means that it is going to stretch. Okay? That means that the graph will actually get skinnier or be pulled in toward the y-axis. Okay, so it's going to stretch vertically. All right, h actually has a value of 2. It's a positive 2. Okay, notice that our form is x minus h, and in our equation we have x minus 2. So the value of h is just 2, it's not negative 2. K has a value of positive 4. Okay? And as our key tells us over here, h moves it horizontally. And if we have a value of positive 2, it's going to move it in the positive direction on the x-axis, which means it's going to move it to the right. Now, since k moves it vertically, and it has a value of positive 4, it's going to move it up. Okay? So we have a stretch thanks to a value of a of 3. It moves to the right because of our h value of 2. It moves up because of our k value of 4. Okay? So if, again, we have our original, our original looks like this. It's going to the right 2 and up 4. So if we go to the right 2 and up 4, our vertex may be up here somewhere. Alright, it's actually going to be, say, here. Alright? And since it is stretched, it's going to be skinnier. So our next graph, if we use the same graph, means it might have moved there. Okay? So it has moved and it is now skinnier. Alright? Let's look at a new function. Let's say I'm going to take the absolute value function now. My generic function is going to look very similar. Okay, h is here still paired with x. All right, it's still doing whatever x is doing. K is tacked on to the end, and a is in front of whatever's going on with x. Let's do minus this time. Okay. So with this equation, we have an a value of -2. Okay? What that tells me is the negative tells me that it is going to be reflected. Which means it is now going to be pointing down. And 2 tells me that it is going to be stretched again. Okay? It's going to be skinnier than it was before. Now, what is the h value here? Okay, if our original generic equation has x minus h, and we have x plus 3, then that tells me that my h value is going to have to be a negative. It's actually going to be -3. Because if I plug in -3 into this, I get x minus -3, which is the same thing as saying x plus 3. So, since it is negative and it moves horizontally, it's going to move it in the negative direction on the x-axis, which means it's going to the left. Okay? So if you see x plus a number, it's going to be moving to the left. Now k is actually -5. And since it moves it vertically, negative is going to move it down. Okay? So, our original absolute value function looks like this. Okay? I'm going to go ahead and draw a new one. I'm going to move my origin a little bit. Okay? I'm going down 5. And I'm going left 3. So my vertex has now moved. Okay? It's going to be pointed down and it's going to shrink, which means it's going to be skinny. So that graph is going to look sort of like that. See, notice it's skinnier than my original. It's pointed down, and my vertex is where h and k are, which is -3, -5. Okay? Alright, so no matter what function you are actually looking at, and you guys should have these in your notes, okay, all these generic functions like this. Okay? H is going to move it side to side. It'll move it either left or right, depending on whether it's negative or positive. It will move it up or down based on k, whether it is negative or positive. The value of A will tell you if it stretches or shrinks, or if it's reflected. Okay? Alright, obviously this isn't comprehensive. You should have notes for that. If you have any specific questions, you can let me know. Okay? This is just a little refresher. Hopefully that helps.